Hello students, today we are going to see some previous year question which was asked in Neet from the chapter Simple Harmonic Motion. Let's start question number 1. A particle executing simple harmonic motion with amplitude A has same potential and kinetic energy at the displacement. So potential energy equal to half m omega square x square equal to kinetic energy equal to half m omega square a square minus x square. So half m omega square cancel out. 2x square equal to a square. So x equal to plus minus a by root 2. So option number 3 will be correct. So x equal to a by root 2. This kinetic energy and potential energy is same. Let's see question number 2. So in this question they have given that two-dimensional motion of a particle. So R can be written as A cos of omega t I cap plus 2A cos of omega t j cap. Now in option they have given the path and the type of motion it is following. So for type of motion, if it is following simple harmonic motion, then I know that it should follow that d square r dt square equal to minus omega square r, because it's doing simple harmonic motion. We have to check now whether this relation is held by this motion r. Let's check. So dr by dt is equal to minus omega a sine of omega t I cap plus minus omega 2a sine of omega t j cap. So this will be minus omega common a sine of omega t I cap plus 2a sine of omega t j cap. Now again do derivative, that is double derivative to get the acceleration. So again if you do derivative, sine omega t derivative will be omega cos omega t. So this will be minus omega square a cos of omega t I cap plus 2a cos of omega t j cap. Now you see here, this is minus omega square r. That means it is following the SHM, or it will obey the SHM. The particle is executing the SHM. If it is executing SHM, then you can say that it will be periodic motion. So option C and D will be correct. Now talk about the path. Let's I am taking this one as a x and this one here y. So x equal to a cos of omega t, y equal to 2a cos of omega t. Y by x is equal to 2, which implies that y equal to 2x. So this is a straight line. The path will be straight line, right? So but there in option there is no straight line, so option C and D will be correct. So fourth will be correct. Now if x equal to 5 sine pi t plus pi by 3 represent the motion of a particle executing simple harmonic motion, the amplitude and time period actually they are asking. So this is given x equal to 5 sine pi t plus pi by 3. You know x equal to a sine, you know that x equal to a sine omega t plus phi. This is your SHM equation, right? So this is your amplitude. So just compare these two. 5 will be your amplitude and it will be 5 meter, because they have given meter here, right? 5 meter will be amplitude and pi is your omega, right? So omega equal to pi. So 2 pi by t equal to pi. So t equal to, you will get 2 second. T t equal to 2 second. So t equal to 2 second and 5 meter. So option number 2 will be correct. Now question number 4. The mass of the simple pendulum is increased to 3x of its original mass and its length is made half of its original length. Then the new time period of oscillation is x by 2 times of original time period. So original time period equal to 2 pi L by G root over. See here there is no dependency of the mass. There is no dependency of the mass. So whether you increase or decrease the mass, there is nothing going to change about the time period of the simple pendulum. Only length is contributing here. So length is changing to L2 L by 3. Right? Original length is made half. Sorry, this should be half, right? Length is making, they are making it to half. This should be L by 2. Length will be L by 2. Now new time period t dash equal to 2 pi L by 2 divided by G root over. That is basically t by root 2. So 1 by root 2 is equal to basically x by 2, because this is x by 2 times they have given, right? So x by 2. So x equal to 2 by root 2, that will be root 2. So here option number 2 will be correct. This should be root 2. Now question number 5. The xt graph of a particle performing SHM is shown in the figure. The acceleration of the particle at t equal to 2 second is. So you see here at t equal to 2 second, it's extreme position at this position, right? And extreme position acceleration, it can be written as minus omega square a. A is the amplitude. So this will be minus omega square. Amplitude is what? 1 meter, right? This amplitude, this is the amplitude 1 meter. And omega can be written as 2 pi by t. This will be 2 pi by t whole square into 1. So time period of this oscillation is how much? You can see here. This will be start from 0 and it will go up to 8 seconds, right? So time period will be 8 seconds for full time period, 0 to 8 up to this one. So minus 2 pi by 8 whole square. So it will be minus pi square by 16, right? So minus pi square by 16. So option 3 will be correct. And you can write down the units meter per second square. Now question number 6. A simple pendulum oscillating in air has period of root 3 second. If it is completely immersed in the non-viscous liquid having density 1 by 4th of the material of the bob, the new period will be. So you can observe here the density of the liquid is less than the density of the bob, right? So it will be completely deep. So this is the condition now. Initially it is like this, no liquid, so time period will be 2 pi L by G root over. Now it will be immersed in the liquid, fully immersed, right? So if it is immersed, what are the forces acting on it? Downward mg and upward there will be a bouncy force, and bouncy force equal to rho vg. Rho is the density of the liquid, v is the volume of the pendulum or simple pendulum, and g is the acceleration due to gravity. So this can be rho, and volume of the simple pendulum can be written as, because mass by volume equal to density of the pendulum, I am writing, right? M by v equal to density. So v can be written as rho p divided by, so this v can be written as here v can be written, this is, I can write rho l, right? Liquid density rho l into volume can be written as mass of the ball divided by rho p, that is the density of the pendulum, into g. Got it? So again they told here that density of the liquid is 1 by 4th of the density of the pendulum. So this is simply 1 by 4 mg then. Got it? So this is your buoyancy force. So mg downward and upward 1 by 4 mg. Net force will be downward then. So net acceleration will be g minus g by 4. That will be 3g by 4. Got it? Because I can draw the free body diagram of this one. This is the pendulum. Upward it will be mg by 4. Downward it is mg. Net acceleration a is downward, so ma equal to mg minus mg by 4. From there I am writing this one. Got it? So 3g by 4 is your new acceleration. Now time period will be what? T dash equal to 2 pi l by g, 3g by 4 root over. So this will be your 2 by root 3 into t. Got it? 2 by root 3 into t. And t is basically initially they have given root 3 second. T is root 3 second. This is your root 3 second. So you can write 2 by root 3 into root 3. This will be 2 second. So option number 3 will be correct. Now two pendulum of length 121 centimeter and 100 centimeter start vibrating in the same phase. At the same instant, the two are at their mean position in the same phase. The minimum number of vibration of the shorter pendulum after which the two are again in the phase at the mean position. So this is basically they are telling that both are in same phase. After how much time they are going to be in same phase. So shorter pendulum is what? 100 centimeter, right? And longer one is your 121 centimeter, right? So I am writing TS, that will be your 2 pi 100 centimeter divided by g root over, and T long is equal to 2 pi into 121 centimeter by g root over. Okay, but if you read this question, they are telling the minimum number of vibration of the shorter pendulum after which two are in again same phase. So let's say n1 or ns, I am taking ns. Ns is the number of vibration after which both are in same phase. So nsts equal to nltl, right? Nl is what? The number of vibration done by the longer pendulum, right? So this will be ns. Ts will be 2 pi into 10 divided by g root over. You just take care of the units because I am not change here, right? This is in centimeter. So because this side also centimeter and both will get cancel out, so I didn't make it to convert into meter. So now this can be written as NL 2 pi 11 divided by g root over. And whatever the unit, they will get cancel out both side, right? So 2 pi get cancel out, g root over cancel out. Ns into 10 is equal to NL into 11. So when they are going to same, so if this is will be 11 and this is equal to 10, then both are going to same, right? And that means the 11 number of, after 11 number of vibration done by the short pendulum or smaller pendulum, both are going to be in same phase, right? So the answer should be 11. So you can see here ns into 10 equal to nl into 11. So if ns equal to 11, then nl has to be 10, right? Okay, now let's go to the next question. Identify the function which represent a non-periodic motion. So first of all, sine of omega t or sine of theta cos of theta or cos of omega t, all these are periodic function, right? You know the graph of all these things. So all these are periodic function. So first option will be your periodic function. Sine of omega t plus pi by 4, it's going to be a periodic function. Sine of omega t again periodic function. If sine of omega t plus cos of omega t, it is also a periodic function. It's right. But this one is not a periodic function, because why? If you draw the graph of this one, at t equal to 0 it will be 1, at t equal to infinite it will be 0, and t equal to minus infinite it is going to be in plus infinite, right? So this is the graph it will look like. So it's a monotonous function, it will be continuously decreasing if you go from 0 to plus infinite, right? Or if you go from 0 to minus infinite, it is continuously increasing. So it is a monotonous function. There is no periodic nature of this function, right? So option number 2 will be correct. Now see the ninth number question. So actually in this question you have to match list 1 and list 2. This will be your list 1 and this will be your list 2. So you have to match this list 1 and 2. So first one graph you see, A graph, this is the amplitude is keep on decreasing. That means there is some friction is happening, that's why the amplitude is keep on decreasing. Just take an example. If I take a simple pendulum and just release it some extremum position or at the extreme position, it will oscillate and after some time it will be come to the equilibrium and stop after some time, right? So this is basically happening due to the friction from the air. Similarly here the amplitude is decreasing, so there should be some friction. Just read all the list 2 option. Total mechanical energy is conserved, so it is not possible for the option A. Bob pendulum oscillate under negligible air friction. If it is negligible air friction, the amplitude will not decay so rapidly. Here the amplitude is decaying very fast, right? The restoring force of the spring, not this one. The bob of pendulum is oscillating along with air friction. Yes, so this one will be your this one. So it is air friction, it is oscillating, so the amplitude is keep decreasing with time, right? Now second one, B option. So here you see this will y and x graph they have given. Total mechanical energy is conserved. This is not possible. So total mechanical energy conserved, which one it will? One D, right? So D will be your I. Why? Because you know that graph between potential energy and kinetic energy is look like this. This will be basically your kinetic energy graph. This will be your potential energy graph, and this dotted line is your total energy. So this is your this graph actually showing that total mechanical energy is conserved. Now bob pendulum oscillating under negligible air friction. If it is negligible air friction means what? This will go into this one, right? The amplitude will not decreasing so fast. It will decreasing but very slowly. Now for this one, B option, this is restoring force of a spring, because you know that F equal to minus Kx. So F equal to minus Kx means the graph will look like this between force and the X. Got it? So the graph will look like this because it's a negative sign is sitting here. So this will be your option number 3. Got it? Now question number 10. A spring stretched by 5 centimeter by a force of 10 Newton. The time period of oscillation when a mass of 2 kg is suspended by it. So spring stretched by the force, right? So x is basically given as 5 centimeter, and x you know that will be F by K. So K you can find out F by 5 centimeter, that will be 10 divided by 5 centimeter. This is Newton, right? So 10 divided by 5 into 10 to the power 2 Newton per meter. So this will be 200 Newton per meter. So K you got. Now you have to find out the time period. So time period equal to what? 2 pi m by k root over. So this will be 2 pi. Mass is given 2 kg. This will be 200. So this will be 2 pi divided by 100. Right? So this will be 2 into 3.14 divided by, so sorry, this should be 10, right? This should be 10. This should be 10. 100 root over will be 10. So this should be 10. So this is coming around 0.628 second. So option number 1 will be correct. A body executing simple harmonic motion with frequency n, the frequency of its potential energy. So x equal to, you know that a sin omega t is your simple harmonic motion equation, and potential energy can be written as half m omega square x square. So this can be written as half m omega square a square sin square omega t, and sin square omega t can be written as 1 minus cos of 2 omega t divided by 2, multiplying here half m omega square a square. So the potential energy actually it is oscillating with half m omega square a square minus, here it will be half m omega square a square cos of 2 omega t and multiplying or divided by 2 here. So actually it is oscillating with what? 2 omega. If you see here, this is oscillating with 2 omega, right? If frequency of SHM is omega, or frequency here you can calculate, this will be 2 pi f. This is going to be what? 2 into 2 pi f. So this is equal to your 2 pi 2f. So frequency is 2 times. So if this is n, this will be 2n. If this is f, this is going to be 2f. Got it? This will be 2n. Similarly, kinetic energy also 2n, right? You should remember. Okay. The phase difference between displacement and acceleration of a particle in SHM. So displacement and acceleration. Displacement is can be written as a sine of omega t. V equal to your velocity equal to a omega cos of omega t. Acceleration equal to a omega square minus of sine omega t. This can be written as a omega square sine of pi plus omega t, right? Because sine minus sine you can take inside pi plus omega t. So if you compare this one, this is a phase of omega t, this is a pi plus omega t. So phase difference between them is how much? Pi is the phase difference between them. So option number 4 will be correct. This should be pi radian. Now go for 13 number question. The radius of a circle, the period of revolution, initial position and sense of revolution are indicated in the figure. So this is the position for t equal to 0, right? And time period is given 4 seconds. The y projection of the radius vector of rotating particle p each. So y projection they are asking. So let's say at any time the particle is at this position. The particle is at this position. So this is your omega t then, and this will be your y projection, right, on y axis. Projection of the radius on y axis, and you know that this will be equal to how much? 3 is the radius, and this will be cos of omega t, right? So now you have to find out the omega. So time period they have given 4 seconds. 2 pi by t equal to omega. So 2 pi by 4 equal to omega, that is omega equal to pi by 2. So this can be written as 3 cos of pi by 2 t. So which option it is? Option number 3, right? This is going to be option number 3. Now 14 number question. The average velocity of a particle executing SHM in complete vibration. So x displacement can be written as a sin omega t. So velocity equal to a omega cos of omega t. For a complete cycle, how the cosine graph will look like? Cosine graph will look like this, right? This will be 0, this will be pi by 2, this will be your pi, this will be 3 pi by 2, and this will be your 2 pi. This will be complete cycle. So average value if they are asking, that means you have to take the area. So you see here, this is area positive, this is area positive, and this full area is negative. If you add all this area, this will give you 0. Or you can find out the average velocity by this formula, right? Average formula, you know, any function f of x, average you can find out f of x integrating from a to b dx divided by dx integration a to b. You can put this formula and get the result for the average value of the velocity, average value of the acceleration, average value of the kinetic energy, everything you can find out all this way. Right, here you have to put the time will be 0 to capital T and you can find out the answer. So which one it will be correct? Option number 4 will be correct, right? Fifteen number, the displacement of a particle executing SHM given by, so y they have given a naught plus a sine of omega t plus b cos of omega t. Now if you see here, this a naught is basically shifting this y. It's not contributing for the SHM, it's only shifting the y. Like that, if I write y equal to 2 plus sine theta. So how this graph will look like? If sine theta will look like this, y equal to 2 plus sine theta, how it will look like? It will look like when y sine theta equal to 0, this will be 2, right? The graph will start from this 2. So the graph will look like this. Got it? So similarly, this A naught is not contributing the SHM, it only shifting the graph. So we have to exclude this part, right? So only this one is doing SHM. And for this part, I can do the phasor diagram, right? So this can be written A sine of omega t plus B sine of omega t plus pi by 2, right? So this will be along this direction A, and at pi by 2 it will be B. The angle or phase difference between them is pi by 2, right? So what should be the resultant here? Resultant will be a square plus b square root over, you know, by vector, right? A square plus b square plus 2ab cos theta. Theta is 90 degrees, so amplitude will be a square plus b square root over, right? So you check here which one should be the amplitude. So a square plus b square root over, right? This should be your amplitude. Okay. A pendulum is hung from a roof of a sufficiently high building and it's moving freely to and fro like a simple harmonic oscillator. The acceleration of the bob of the pendulum is 20 meter per second square at a distance 5 meter from the mean position. The time period of the oscillation. So this relation it is known to us. A equal to minus omega square x. So acceleration they have given 20 equal to minus omega square into x they have given 5 from the mean position, right? So omega square equal to how much you will get magnitude wise, this will be get 4, right? So omega equal to 2. So 2 pi by t equal to 2. So t equal to pi second. So the time period will be 5 seconds. Now question number 17. A spring of spring constant K is cut into length of ratio 1:2:3 are connected in series and their new force constant is K dash. They are connected in parallel and force constant is K double dash. Find K dash is to K double dash. So K dash is for series and K double dash is for parallel. So this is one spring is there, spring constant K and length L. It will be cut into 3 parts. 1:2:3, 3 parts. So this length will be L by 6, this length will be 2L by 6 and this length will be 3L by 6. 1:2:3, right? And you know that for a spring, the spring constant is inversely proportional to the length. So this should be your, the spring constant will be 6K, this will be 3K, this will be 2K then. Because this is equal to how much? L by 2. This is equal to how much? L by 3. Right? So this should be your spring constant now. Now 3K, 6K, 2K in series. So K dash 1 by K dash can be written as 1 by 6K plus 1 by 3K plus 1 by 2K. This will be 6K, 1 plus 2 plus 3. So this will be 6. This will be 1 by K. Got it? So K dash you will get K. Now K double dash, when it is in parallel, you know that this should be 6K plus 3K plus 2K. This will be 11K. Right? So K dash is to K double dash equal to K is to 11K. That will be 1 is to 11. So option number 2 will be correct. Okay. So you should remember for parallel connection of the spring, it will be K equivalent equal to K1 plus K2 plus K3, and for series it will be K equivalent 1 by K equivalent equal to 1 by K1 plus 1 by K2 plus 1 by K3. Like that you have to write. This thing you have to remember. Now 18 number question. A particle executes simple harmonic motion with an amplitude 3 cm. When the particle is at 2 cm from the mean position, its magnitude of velocity equal to that of acceleration. Okay. So amplitude is given as 3 cm. When the particle is at, so x they have given 2 cm. This is from the mean position, right? This will be 2 cm. The magnitude of velocity equal to that of acceleration. So v equal to what? Omega into s square minus x square root over. And acceleration equal to what? Minus omega square into x. So v equal to a they are saying. So omega square x equal to, in magnitude wise I am only writing. This will be s square minus x square root over into omega. So omega, so one side omega, this omega and omega cancel out, only omega will be there. X equal to, I am writing 2 cm is equal to s square minus x square root over. And a equal to value, you know that 3 square minus 2 square, x equal to 2 square root over. This will be 9 minus 4, this will be root 5. So omega equal to root 5 by 2. Time period they are asking. So if they are asking time period, this will be 2 pi by t equal to root 5 by 2. So time period will be 4 pi by root 5 second. So 4 pi by root 5 second. So this one will be correct. 4 pi by root 5 second. A body of mass m is attached to the lower end of a spring whose upper end is fixed. The spring has negligible mass. When the mass m slightly pulled down and released, it oscillates with a time period of 3 seconds. When the mass is increased by 1 kg, the time period becomes 5 seconds. What is the value of mass? So, first of all, this is a spring mass system. So, initially time equal to 2 pi m by k root over. Now, finally t days is equal to, they are telling 2 pi into m plus 1, 1 kg release, this will be increase m plus 1 by k root over. And t equal to value they have given 3 seconds, right? Oscillate with 3 seconds. This will be 3 seconds. And t days value they have given 5 seconds, right? So just this is equation number 1 and this is equation number 2. Just divide 2 divided by 1 if I do. This will be simply 5 by 3 equal to 2 pi cancel, m cancel. This will be m plus 1 divided by m root over. So this will be 25 by 9 equal to m plus 1 divided by m. So 25m equal to 9m plus 9. So this will be 25m minus 9m. This will be 16m equal to 9. So m equal to 9 by 16 kg. Right? So option number 4 will be correct. 9 by 16 kg. Not good. A particle executing SHM, its maximum acceleration is alpha and maximum velocity is beta. Then time period of the vibration. So maximum acceleration. So alpha equal to minus omega square a, because maximum acceleration is observed at the extreme position and extreme position x equal to a, right? And maximum velocity is beta. So beta equal to omega into a square minus 0 square, because to the power half, because maximum velocity or maximum speed is observed at the equilibrium position, for which the x value is 0, or mean position x value is 0. This is equal to omega into a. Now they are asking for the time period. So if I take the magnitude here, this will be omega square into a. So alpha by beta is equal to simply omega square a divided by omega a. That will be omega. So this will be 2 pi by t equal to alpha by beta. So time period equal to 2 pi beta by alpha. So option number 2 will be correct. Let's see question number 21. Right. So particle is executing SHM along a straight line. Its velocity v1 and v2 at a distance x1 and x2 from the mean position respectively. Its time period is. So if you see here, in this time period there is no amplitude is there, right? So what we have to do, I can write v1 equal to omega into a square minus xn square to the power half, and v2 equal to omega into a square minus x2 square half. So v1 divided by omega whole square is equal to a square minus x1 square. v2 divided by omega whole square equal to a square minus x2 square. Right? So I have to eliminate the amplitude. So I can write v1 square. This is equation number 1 and equation number 2. So I can write v1 square divided by omega square plus x1 square is equal to v2 square divided by omega square plus x2 square. So v1 square minus v2 square divided by omega square is equal to x2 square minus x1 square. So omega square value you can get here v1 square minus v2 square divided by x2 square minus x1 square, and omega equal to 2 pi by t, so this can be written as 2 pi by t whole square. So t can be written as, now t I can write 2 pi x2 square minus x1 square divided by v1 square minus v2 square root over. So you can write down and see this relation. I am writing directly because you see here, this will be omega square equal to 2 pi by t square. So t obviously equal to 2 pi into x2 square minus x1 square divided by v1 square minus v2 square root over. Okay. Now question number 22. When two displacement represented by y1 equal to a sin omega t and y2 equal to b cos omega t are superimposed, the motion is, so just superimpose both y1 plus y2 equal to a sin of omega t plus b cos of omega t. Just add it, right? So this type of question we see recently, right? So this can be written as a sin of omega t plus b sin of omega t plus pi by 2. So this is your phasor diagram. This is A, this is your B because phase difference is pi by 2, and resultant you can get a square plus b square root over. A square plus b square root over is the resultant amplitude. So SHM with amplitude, this will be a square plus b square root over. So option will be, this one will be correct. So why it is SHM? Because you see here both are omega, right? This is omega and this is also omega. Both same frequency it is. If there is same frequency superimposed, it will give you a SHM, right? So, and both are in same direction they are telling. Or you can prove here, right? So y1 plus y2, if you do double derivative this one, so what you will get? First derivative will be cos omega t, omega will come outside, and second derivative will be minus sign will come, right? Minus omega square sin of omega t will come. So let's say this is equal to y equal to this much. So d square y by dt square is equal to minus omega square a sin of omega t plus b cos derivative. First cos derivative will be your minus sign, and sine derivative will be cos. So you can write down the derivative. This will be cos of omega t. So this will be minus omega square will come. So minus omega square, and this will be your y again. So this is following the SHM. You can write down the derivative, right? You know the derivative, d by dt sin of omega t is equal to omega into cos of omega t. Again, if you do derivative, you will get minus omega square sin of omega t, and derivative of cos of omega t is basically minus omega sin of omega t, right? Now see question number 23. SHM is given x equal to a cos omega t. X is the displacement at time t, and omega is the frequency of the oscillation. Small a is given the acceleration and t is the time period. Which of the graphs show the correct variation of a? A is the acceleration variation they are telling. So x equal to a cos omega t they have given a cos of omega t. So v equal to what? Dx by dt equal to minus a omega sin of omega t, and acceleration equal to d square x by dt square, that is equal to, again you have to do the derivative, minus omega square cos of omega t, right? So there is a negative sign is here. So when t equal to 0, the acceleration will be minus a omega square, right? So t equal to 0. So which one it is matching? Minus, you can see, right? This one it is matching. 24 number. A particle of mass m oscillates along x-axis according to the equation x equal to a sine omega t. The nature of the graph between momentum and displacement of the particle. So x is your displacement, right? X equal to a sine of omega t. A is your amplitude here. So v is your velocity, can be written as dx by dt. So this will be a omega cos of omega t. So the graph between momentum and displacement. If the velocity and displacement graph same as momentum as and displacement graph, because if you multiply mass here with the velocity, you are going to get the momentum, right? So x equal to a sine of omega t, v equal to a omega cos of omega t. So x by a equal to sine of omega t, and sine of omega t can be written as 1 minus cos square omega t root over. So x by whole square is equal to 1 minus cos square omega t, that is equal to 1 minus cos omega t value is how much here? You can get here cos omega t value equal to v by a omega. So this is simply v by a omega whole square, right? So x by a whole square plus v by a omega whole square equal to 1. So this is which type of equation? If you remember, this will be ellipse, right? Why? Because ellipse equation is what? X square by a square plus y square by b square is equal to 1. This is the ellipse equation. So this is coming as ellipse equation, right? So which one it will be true? Option number C will be correct. Now see, 25 number question. Two particles are oscillating along two close parallel straight lines by side with the same frequency and amplitude. They pass each other moving in opposite direction when the displacement is half of its amplitude. The mean position, right, of two particles lie on the straight line perpendicular to the path of the two particles. The phase difference is. So what they are basically telling, this is one particle is moving and in the another parallel path both particles are moving. So let's say this is their mean position. This is their mean position. And both have same frequency amplitude. Both have same frequency and amplitude. So this is your minus A. This is also minus A. This is plus A. This is plus A. Right? They are telling that they pass each other moving in opposite direction when displacement is half of its amplitude. So displacement is half of its amplitude is what? This position, right? A by 2. So let's say they're starting from the mean position, right? One is starting from the mean position. It is moving like this. Another is moving like this. Why they are moving like this? They are telling that moving in opposite direction, right? When the displacement half of its amplitude. So one is moving along this direction and another one is moving along this direction, and they meet at a by 2. Now their phase difference I have to find out. For let's say this one is particle number 1, this one is particle number 2. For particle number 1, what should be the phase? I can write x equal to a sine omega t, because they are starting from the mean position, right? It's a sine omega t. So at a by 2, if I want to find out the phase at a by 2, this will be a sine omega t. So omega t now equal to simply pi by 6. So first one is phase. I can write phi 1 equal to pi by 6. Now go for the second particle. Second particle x equal to, again this will be a sine omega t, but this time this particle is not moving along positive x-axis, it is moving in opposite direction. So if I want to find out the velocity, this will be given as a omega cos of omega t, right? And I want this v to be negative. I want this v to be negative and x to be a by 2. So there is a possibility that if you put pi by 6, you will get the answer, or you can put 5 pi by 6 also, you will get the answer. For pi by 6 here, you will get a positive. If you put pi by 2 here, v will be your positive. But I need a negative value of v, because v is now along this direction. If you v is, this one is along this direction positive, this direction it will be negative, right? Because it is moving along this direction. So for negative, I need 5 pi by 6. So here I have to choose the phase is 5 pi by 6. So phi 2 equal to 5 pi by 6. Got it? So now the phase difference will be phi 2 minus phi 1. So phi 2 minus phi 1 is equal to 5 pi by 6 minus pi by 6 is equal to 4 pi by 6. This will be 2 pi by 3. So option 3 will be correct. Now go to the next question. Out of the following function representing motion of the particle, which represent SHM? Which one actually representing the SHM? First one, if you see, this is omega is sitting here. This is also omega. This type of question we have seen now recently, right? Y equal to a sine omega t plus b cos omega t. All these are performing SHM. Just now we have proved. So this one obviously will be SHM, right? Or you can find out d square y by dt square equal to minus omega square y. You can find out for this one. This will be hold for this one. Now sine qt is not an SHM, right? This is not an SHM. You can prove. Again you have to follow this one, d square y by dt square equal to, if it is minus omega square y minus omega square y, then it will be SHM. If it is not following this one, it is not an SHM. Now for this one, third one also, you will find out this is going to be follow this relation. Now this one will not follow this relation. So 1 and 3, these two will SHM. Option 1 and option 3 will be your SHM. Okay. Now go for the 27 number question. X equal to a sine square omega t, motion of the particle will be. So basically in NCERT, if you see this x equal to a sine square omega t, they have written this is a periodic motion. They have written this is periodic and harmonic. They never talk about this is a simple harmonic motion. And obviously this is not going to be a simple harmonic motion. This is a periodic motion basically. So you can say that this will be non-SHM. Basically what you can, again you can find out this one in this format. D square x dt square is equal to minus omega square. If this is holding, then you can tell this will be your SHM. If it is not holding, this is not SHM, right? So this motion is periodic and harmonic, but not simple harmonic motion. So this will be non-SHM, right? Now question number 28. The period of oscillation of mass suspended from a string of negligible mass is T. If along with it another mass M also suspended, the period of oscillation will be. So if you see here, the time period will be 2 pi L by G root over. So it is independent of mass. independent of mass. So if you increase that mass, the time period also be same. So option number 1 will be correct for sure. Now 29 number question. A simple pendulum performs SHM about x equal to 0 with an amplitude A and the time period is t. The speed of the pendulum at x equal to a by 2. So v equal to, we know that omega into a square minus x square root over. This will be omega into a square minus a square by 4 because x equal to a by 2 root over. So this will be 2 pi by t into root 3a by 2, right? So this should be your I can write this one, 2 get cancel out, root 3 a pi divided by t will be your speed. So which option it will be? 3, root 3 a pi divided by t. Question number 30. Which one of the following equation of motion represents simple harmonic motion? So you can check here. So simple harmonic motion, for simple harmonic motion, you know that f equal to minus kx. So you check here which one is minus kx is holding. This one x square term is sitting here. So it cannot be simple harmonic motion. This kx also it is not. This is plus is there, it is not possible. So this one is possible, right? So f can be written as minus kx minus k, right? So this is a constant. So minus kx plus c. This will be your simple harmonic motion. Here x square is sitting, so it cannot be SHM, right? For SHM there should be a restoring force, and that restoring force should be directly proportional to the displacement from the mean position, right? And x is the displacement from the mean position. And here a is a constant, so we can take this one as a SHM, right? They have given the acceleration value, so I am taking the force, so you can take the acceleration value also. Okay. Which of the following equation of motion represent the simple Which of the following equation of motion represents simple harmonic motion? So acceleration they have given. So for acceleration, you know that this will be minus omega square into x, right? So this cannot be possible because x square term is there. This is also not possible because there is no negative sign, and kx plus a also it is not possible because k is given as positive, right? If k is any constant, you can consider it is a negative, but now you cannot consider k is negative because k is already given as positive, right? Now this option is possible because this can be written as minus kx minus ka minus kx plus some constant here. So if this constant is sitting, this can be a SHM, right? So acceleration equal to minus omega square x, and this is minus kx is sitting here. So this can be your a simple harmonic motion. Two simple harmonic motion of angular frequency 100 and 1000 radian per second have same displacement amplitude, ratio of their maximum acceleration. So displacement amplitude are same. So both are a. So maximum acceleration a equal to minus omega square a. This will be a max value, right? So you can find out, let's say a1 divided by a2 equal to omega 1 square divided by omega 2 square. So omega 1 will be how much? 100 square divided by 1000 square. So this will be 1 by 10 whole square. This will be 1 by 100. So option number 4 will be correct. A particle executes simple harmonic oscillation with an amplitude A. The period of oscillation is T. The minimum time taken by the particle to travel half of the amplitude from the equilibrium position. So this is your SHM minus A. This is your plus A. This is x equal to 0. Equilibrium position. This is A by 2. So they are asking how much time it will take from 0 to A by 2. So A by 2 equal to A sine of omega t, right? So omega t value equal to how much? So basically this is coming x equal to a sine omega t, and x equal to a by 2. I just want to find out the omega t value. Omega t will be obviously pi by 6 because sine pi by 6 value is a by 2. Okay, so omega equal to 2 pi by t into small t equal to pi by 6. So small t equal to pi, small t equal to basically pi pi get cancel out both side, pi pi get cancel out both side. T equal to small t equal to capital T divided by, this will be 12. So capital T is your time period, right? This will be time period. So which option it will be? T by 12. So now you can remember this thing, because again you don't have to calculate. This is x equal to 0 and this is plus a, this is minus a. So here to here it will take t by 4 time from mean to extreme. Again from here to here it will take t by 4. From here to here it will take t by 4. Again t by 4. And half you got now t to t by 12. From 0 to a by 2 this will take t by 12 second. And a by 2 to a, this will be taking around t by 6 second. You should remember all these things. So they have asked from x equal to 0 to a by 2, this will be t by 12 second. Now x equal to a by 2 to a, this will be t by 6. Okay, yes. A mass of 2 kg put on a feed pan. A mass of 2 kg put on a flat pan attached to a vertical spring fixed on the ground as shown in figure. The mass of the spring and pan is negligible. When pressed slightly and released, the mass execute SHM. Spring constant is 200 Newton per meter. What should be the minimum amplitude of that motion so that mass get detached from the pan? So detached means what? So that means normal is going to be 0. So if something is lifting from the pan means there is no normal force existing now. So let's say this is your flat pan, right? And on it the mass is there. So when you can imagine when this mass is going to lift up, when it is only possible when this pan is at maximum position and it is moving down, then only it will be possible, right? Got it or not? So it will be moving down and it will be at maximum position. So I can show you here that, let's say this is your equilibrium position of this pan, right? At this position this will be your mg and this will be your, I can say that this will be ky along this direction. Now this is your extreme position. Extreme position, what's going to happen here? At extreme position you know that there will be a normal force and downward mg is there and the acceleration will be downward, right? Because at extreme position the acceleration will be downward and acceleration will be minus omega square a, right? And downward it is because minus sign is sitting here. And at another extremum position, that is your minus a position, at this position what's going to happen here? The normal force will be n is upward, mg is downward, but the acceleration will be upward omega square a. So only possibility that the pan will be moved from that flat, sorry, the mass will be moved from the flat pan at this position because it's moving down, and that time only possibility the normal is going to be 0. So let's write down the equation of motion at this point. So we will tell that it's moving downward. So mg minus normal equal to m omega square into a. A is the amplitude, right? If normal equal to 0 at this position, normal equal to 0 at this position, because it's going to detach, right? Mg equal to m omega square a, and g equal to omega square, g equal to omega square a. So they are asking the amplitude. So amplitude will be what? G by omega square. Now put all the value. Amplitude equal to G equal to 10 divided by omega. Omega you can find out here, 2 kg mass, and spring balance how much they have given? Here they have given 200, right? 2 kg mass and 200 is your K value. So omega value is simply K by m root over omega square will be K by m. So 10 into m value is your 2 kg divided by K value is 200. So this will be 1 by 10, right? 1 by 10 meter. Now amplitude equal to 1 by 10 into 100 centimeter. This will be 10 centimeter. Option number A will be correct. A particle executing SHM has a kinetic energy k naught cos square omega t. The maximum value of potential energy and total energy are respectively. So kinetic energy equal to k naught, sorry, k naught only, na? Should be k naught into cos square omega t. That maximum value will be how much? K max equal to k naught, right? And you know that maximum value of kinetic energy is same as your total energy is same as your maximum value of potential energy, because this graph, you know, this will be your minus a plus a, this will be your here total energy, and this graph is basically your at extremum position that kinetic energy 0. So this box of mass m, cross sectional area a, floats in liquid of density rho. If it given a small vertical displacement from the equilibrium, it will undergo a time period t. So they are asking the time period t and relation. So let's say this is a container in which the liquid is there, right? And this is the block, rectangular block, let's say, and this is the length L, which is submerged in the liquid. And if you slightly displace this one, and it will do SHM, right? So first equilibrium condition here, mg is equal to your buoyancy force. This is mg and there will be a buoyancy force, and buoyancy force value it is known to you, that will be density of the liquid rho L into volume of the solid which is submerged in the liquid into g, and I can write mg equal to rho L, and volume will be area into this length into g. Length is the L is the length submerged in the liquid, right? The length of that or height of that rectangular box which is submerged in the liquid. Okay. So this will be your equilibrium condition story. Now if you slightly displace this one, so this is your liquid is there, and now let's slightly displace. So this is going to happen. So now it will be going to L plus, let's say, X. L plus X. So I can take this one, L plus X distance it is now. Okay, this will be L plus X. Now for this, you can say that the net force will be now upward because buoyancy force will be more now. So acceleration, mass into acceleration can be written as now your buoyancy force, new buoyancy force minus mg, because mg is downward. So new buoyancy force will be how much? Rho L into volume submerged, right? That is new volume into g minus mg. So rho L volume can be written as A. Now the length will be how much? L plus X into g minus mg. Got it? So acceleration will be, or mass into acceleration will be rho L A L G plus rho L A X G minus mg. So mg equal to rho L A G. So these two are getting cancelled out. Got it? So acceleration equal to now rho L A G divided by m into x. Right? This is your acceleration, magnitude of acceleration, and SHM is satisfied here because you are giving a displacement downward and it is the force is upward, right? Because the buoyancy force is more, so the force is upward, but you are giving a displacement downward x. So this will be your acceleration. Now you can get the time period easily because you know that acceleration equal to minus omega square x. Omega minus is showing that it's will be opposite direction of the acceleration is opposite direction of the displacement. So omega value you can get rho L g divided by m root over. So t is equal to omega equal to 2 pi by t. This is equal to 2 pi by t. So t equal to basically 2 pi m divided by rho L A G root over. So T is proportional to what then? Rho L is your density of the liquid, right? Rho L here, right? So rho L density of the liquid, this is same as rho because they have given rho equal to density of the liquid. So this will be your answer, m by rho L Ag. So they have given the proportionality constant, you can check here, right? So this will be not proportional to 1 by m, not proportional to, directly proportional to rho root over. So it will be option number 3. So this is the actual way to do this question, but you can do this question very fast because you see here there is no contribution from the mg because mg is a constant force here. Got it? Mg is a constant force here. So what you can say that if there is no contribution from the gravitational force or mg, the acceleration will be come from this buoyancy force actually. Got it? So from this buoyancy force you can see here this is rho ALG, right? And the acceleration basically you can write down from here directly, that is going to be rho Ag divided by m. Got it or not? You can directly write down this without doing all this calculation. Okay. So I'll give some example on this question. You can get to know that. So let's say here I can give one example. Let's say there is, I am asking that this is a spring mass system. If I ask what should be the time period of this one, you will take 2 pi m by k root over, right? So if you solve this one also, you will get this answer, but mg has no contribution here. Mg has no contribution here. Mg is a constant force here, so it will not affecting the time period. Similarly, if I give this type of situation, let's say, and this is the situation, and there is a mass is there, m mass, and there is a spring is there. If I ask time period, so here also time period 2 pi m by k root over. So there will be no contribution from the mg side in the time period because mg is a constant force. Similarly, here there will be no contribution from the gravitational force on the time period. So you can directly find out here, right? Okay. Now 37 number question. The circular motion of a particle with constant speed is. So circular motion it is doing. So it is a periodic, right? Not SHM. Because you know that if this is a uniform circular motion because constant speed, the projection can be, this is your equilibrium position, this is your extreme position, this is another extreme position. The projection is actually SHM, but that motion itself not SHM. What is? That will be periodic but not SHM. Clear? But the projection, you know that we can project uniform circular motion on a straight line, and this straight line will be going to be SHM, right? We have solved this type of problem to find out the time period also. Now 38. Two spring constant K1 and K2 are joined in series, the effective spring constant. So if it is series, 1 by K equivalent equal to 1 by K1 plus 1 by K2. So K equivalent equal to K1 K2 divided by K1 plus K2. So option number 4 will be correct. Now 39. SHM, they have given amplitude 5 and maximum speed 31.4, frequency of the oscillation. So maximum speed V equal to omega into A. So maximum speed 31.4 equal to omega into A equal to 5 centimeter. Right? This is also in centimeter per second. Both sides centimeter get cancel out, right? So 31.4 equal to 2 pi f into 5. So you have to find out the frequency now. So this will be 10 pi f. So 10 into 3.14 f. So 3.14 cancel out. So f will be simply equal to 1 Hz. So fourth option will be correct. 40. Which of the following true? V is speed and A is acceleration for a SHM. This is for, obviously for the SHM they are asking. So if you know that this will be your extremum minus A, this will be extremum plus A, this will be 0, right? So let's start from this mean position. At mean position, your V is maximum and A is equal to 0 because at mean position the speed net force is 0, so acceleration will be 0. And here V will be 0, A will be maximum. And here V will be 0, A will be your maximum. Now we can check here. So when A is maximum, V also maximum, this is not possible. A equal to 0, whatever the value of V, no. A equal to 0 means V should be maximum. When V equal to 0, A equal to 0, this is not possible. When V is maximum, A is 0. When V is maximum, A is 0. This is your mean position. This will be true. And I can tell you here that here kinetic energy is maximum. Sorry, kinetic energy is minimum, or kinetic energy basically 0, not minimum actually. This is kinetic energy actually 0 here. So here, because speed is 0, kinetic energy is 0, and potential energy here maximum. Here potential energy similarly maximum, kinetic energy equal to 0. And here kinetic energy is your maximum and potential energy is 0. So kinetic energy maximum value is equal to same as potential energy maximum value. When kinetic energy maximum value same as potential energy maximum value, and that is equal to total energy, that is equal to half k a square, or this can be written as half m omega square a square. So this thing you can remember. Okay, so next question. The potential energy of a simple harmonic oscillator when the particle is halfway to its end point. So this is your, just now we talked, right? This will be minus a, this will be plus a, this will be 0, this will be a by 2. Here they are asking the potential energy actually, right? So potential energy can be written as half k x square, here equal to half k a square by 4, because x equal to a by 2. Now this will be half k a square into 1 by 4, and total energy equal to what? E is total energy. So E is basically your total energy. So total energy, so we can write down here E is your total energy. So E equal to total energy, E equal to, you know that, half k a square. So this is equal to E by 4. So option number 3 will be correct. So you could remember, right? E is total energy. So you know this one, E is total energy equal to total energy, E by 4. Now 42 number question. A particle of mass m oscillate with SHM. The graph of potential energy versus displacement. So now just discuss right here what's going to happen here. So potential energy maximum where? At extremum position, right? And kinetic energy maximum at mean position. So we can see here. So potential energy is maximum at extremum position. So it's maximum here, plus n minus n, and 0 at mean position. So option number 1 will be correct. What should be the graph of kinetic energy if I draw? This will be your plus a minus a, this will be minus a, this will be plus a. The graph will obviously look like this, right? So this is your kinetic energy graph, and this is your total energy here, or maximum kinetic energy, E. Now 43. The time period of mass suspended from a spring is T. If the spring cut into 4 equal parts and same mass suspended one part, then new time period. So first, this is the spring K. Here the time period is equal to 2 pi m by k root over. Now it is changing. They are cutting it to 4 parts. So each has length L by 4, L by 4, L by 4, L by 4. So if this is length is going to be L by 4, the spring constant will be 4K, 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 4K. Now you choose one spring and do the same experiment. This is your spring and you put the mass M, and spring constant will be 4K. So So now time period will be 2 pi. Now the time period will be 2 pi m by 4k root over. So this will be 2 pi by 2 m by k root over. So this will be t by 2. So option number 3 will be correct. So if the spring length is decreasing, the spring constant will keep on increasing because k into L is constant. For a spring constant into length is constant. If length is decreasing, k will be increasing. If length will be increasing, k will be decreasing. This thing you have to remember, right? Now 44. Displacement between maximum potential energy position and maximum kinetic energy position for a particle executing SHM. Same type of question. This is 0, this is plus a, this is minus a. Here kinetic energy 0, potential energy maximum. Here kinetic energy maximum, potential energy minimum, or potential energy not minimum, actually potential energy equal to, yeah, this is minimum and that value we can write, right? This is 0, right? Potential energy will be 0. Now they are telling the displacement between minimum potential energy. So minimum potential energy is this one, and maximum kinetic energy this one or this one also, right? This will be Ke minimum, that is equal to 0, and Pe maximum. Maximum potential energy is this one, and maximum kinetic energy is this one. The displacement will be 0 to x equal to a, the a, right? And this side also it is possible. Maximum potential energy is here, and maximum kinetic energy here. This will be your minus a displacement. So the answer will be plus minus a. Got it? So option number 3 will be correct. So plus minus a. So this side it will be possible, and this side also it will be possible. This will be plus minus a. Now 45. The mass is suspended two different spring in successive order. Then time period is T1 and T2. So initially what they are telling, if the mass is suspended from, this is K1 and the time period is T1. So T1 equal to what? 2 pi m by K1 root over, and separately it also hanging here with K2. The time period T2 equal to 2 pi m by K2 root over. Now both are in parallel. If both are in parallel, what will be the time period? The K equivalent, it will be m. So K equivalent will be what? K1 plus K2. So T naught equal to 2 pi m by K1 plus K2 root over. For parallel case, you can add K1 plus K2 like this. Now we have to find out the relation between this, right? So T naught, here I am solving this one. T naught is written as 2 pi m by K1 plus K2 root over, right? So 1 by T naught square is equal to 1 by 4 pi square K1 by m plus K2 by m, and that is 1 by 4 pi square K1 by m. This, if you see here, this can be written as 1 by T1 square equal to 1 by 4 pi square K1 by m, right? So 1 by 4 pi square K1 by m equal to how much? 1 by T1 square. Similarly, it can be written as 1 by T2 square. So I can write T naught minus 2 equal to T1 minus 2 plus T2 minus 2. This should be your answer. 45 number question, option number 2. Total energy of a particle performing SHM depends on. So total energy equal to half K A square. Right? So this is depending on the amplitude. Amplitude small a they have given. So half K A square. So depending on K and A. So option number 2. 47. Two masses M, A and B are hung from two strings of length L1 and L2, LA and LB respectively. They are executing SHM with frequency relation FA equal to 2FB. Then the relation so they are asking the relation between length actually. So you can find out here time period TA equal to 2 pi LA by G root over and TB equal to 2 pi LB by G root over, and frequency if you want to write here this will be 2 pi by TA. So FA equal to G by LA root over, FB equal to G by LB root over, right? And they have given, I can take this one equation number 1, this will be equation number 2. FA by FB is equal to LB divided by LA root over. So FA equal to 2FV. So this will be 2 square is equal to LB by LA. So LA equal to LB by 4. LA equal to LB by 4. So in this option, so you can, I just made it mistake when writing. So this is given 4, LB by 4, right? So option number 1 will be correct, and obviously this is independent of mass. Frequency is independent of mass. You can see the time period and you can see that frequency also, it is independent of mass, right? So option number 1 will be correct, LA equal to LB by 4. So it will be independent of mass. So this is the last question, 48 number question. The simple pendulum having length L is displaced from mean position to angular position theta with vertical. If it is released, then the velocity of the bob at equilibrium position. So basically this is the condition they have given. So this is your pendulum and it is following a path like this, right? So it is at this position having angle theta. Now at this position it's going to release. This length is L. So you can get this velocity at this position by applying energy conservation. So let's apply the energy conservation at this point and at this point. This is A point, this is B point. So this is at rest here, right? And you know that if this is theta, this length is going to be L cos theta, and this length will be L 1 minus cos theta, right? This will be L1 minus cos theta. Okay, so let's total energy at A is equal to total energy at B. Apply the conservation of energy because there is no dissipating force or something is there, so you can non-conservative force is there, so you can apply the total energy conservation, right? So I can write down here total energy at A, potential energy will be, sorry, kinetic energy will be 0. So kinetic energy at A plus potential energy at A is equal to kinetic energy at B plus potential energy at B. So now kinetic energy at A. So kinetic energy at A equal to 0 plus potential energy will be, if I take this potential energy here equal to 0, so potential energy at this point will be mg L 1 minus cos of theta is equal to kinetic energy at B will be half mv square plus potential energy will be 0. So V will be 2gl because m get cancel out, 2gl 1 minus cos of theta root over. So option 1 will be correct.